Well, ain't no fun until Alfredo's here. Thank God Alfredo showed up. What are we gonna do?
Alfredo, bring Alfredo. They don't,
So he brought Alfredo.
so,
The question is, did he bring chicken? There's always Alfredo.
Alfredo, no chicken.
No, that's not where I was going with that.
I know.
I realize what. Content, this is day 7, alright, so. We're gonna hit on some algebra stuff and some word problems. Like reading them, because this class is a class filled with word problems. So math has letters in it. As soon as you're out of lower arithmetic stuff. Math has letters in it, this is algebra. And letters. Also called variables. Represent unknown quantities. Or. Amounts that can vary. Hence the name variable, variable. So we could have something like. 2x plus 3y equals 6. We don't necessarily even need 2 letters, we can have 1 letter. It could be something like. 3x plus 5. Equals 14. When there's only one variable. There's only one variable here. There is usually only one value that will make this true. And it turns out in this case. 3 times 3 plus 5 equals 14. So x equals 3 makes this true. When there's 2 variables, 2 or more variables. There's a whole wide range of solution. A wide range of solutions. That meet this. For example, if I say x equals 0 and y equals 2. And this becomes 2 times 0 plus 3 times 2 equals 6. And that's true, 6 equals 6. I could also go with x equals 3, y equals 0. And we get 2 times 3 plus 3 times 0 equals 6. Also true. But when there's more than one variable, once one value is locked in. We usually call this the independent variable. The other variable. It has only one possible answer. Result that will work. And we call this the dependent variable. Oftentimes, the independent variable is X. And the dependent variable is Y. The way we tend to use it. So Y's value depends on what we pick for X. Okay, you want me to sit longer?
Alright.
So. I had 3x plus 5 equals 14. That was the example I gave earlier, and we showed that 3 times 3 plus 5 equals 14. Because this is 9 plus 5, and that plus 5 is 14. Usually we don't know the value for x, but we can solve for it. So we can solve an equation to determine the answer. The goal is isolate the variable. So right now, x has a 3 multiplied by it and a 5 added to it. It's usually easiest to do the deal with fractions first. Fractions or decimals by clearing them. With multiplication. And then 2. Deal with the value added or subtracted. Any added or subtracted value. And then 3. Deal with the number being multiplied by it. And we'll do all that right here. Well, we don't have fractions, so we won't do the fractions separately. So watch what happens, I'm gonna do it to both sides. There's no fractions here, so I'm gonna deal with any added or subtracted value. The way you would get rid of 5 extra pounds is you would lose 5 extra pounds, right? So we're gonna deal with things by doing the opposite symbol. And whatever I do with it, I have to do with both sides, I gotta keep it balanced. This is like a scales. And if I do that, the 5 minus 5 goes away, there's nothing left on the left but 3x. The right is 14 minus 5. Notice that if I do this over here. I still have a true statement the whole way. Generally, you don't know the 3 though, I'm just showing you that this is why this works. And then this is multiplied by 3. The opposite of multiplying is dividing, so we're gonna divide by 3. Or you can multiply by the reciprocal. Multiplying by 1/3 is the same thing as dividing by 3. But if I do that, the 3's cancel and I'm left with x equals 9 divided by 3 is 3. And this is where my x was the whole way. Do the same process over here. I still get 3 equals 3, but now the balance is maintained the whole way, that's the key. So if you don't do the same thing to both sides, you're kind of fucking it over, it's not gonna work, it's gonna be the wrong answer. Let's say we had 2x minus 1 equals 9. I am deliberately going to do this wrong. Intentionally. And I'll do it right away. I will add 1 to both sides. To get rid of the thing added to it, and I'm gonna say 2x equals 11. Now, hopefully you all recognize 9 plus 1 does not equal 11, that's the mistake. But there's a reason for this. I think, let's make this a little easier, let's make it 12. That's still a mistake, but it makes the next step a little bit easier. Then I can still do that, instead of dividing by 2, I'm gonna multiply by 1/2. This is a valid step. I'll do this in red. And the 1/2 and the 2 go away, I'm left with x equals 12 times 1/2 is 6. When you have an answer and you plug it in. You can check your answer by plugging in. And I'm gonna plug it into the very original equation. 2 times 6 minus 1, does that equal 9? I get 2 times 6 is 12. 12 minus 1, does that equal 9? 11 does not equal 9. So I've shown. By getting an answer that doesn't work. This says x is not 6. So I made a mistake. I either made a mistake in where I checked it, or I made a mistake where I was solving it. So if you're solving algebra equations for a value, you can always go and check to see if it worked. But you gotta go and plug it into the very first starting line. Correct way to do that would obviously be. You add the 1 and we get 10. On the right. And divide by 2 and we get x equals 5. Now when we check our work. N minus one does equal 9. Any questions? Uh, next part. If we have fractions. Let's go with 3/5. Way to go about this is to clear fractions. By multiplying by a common denominator. You can always. Multiply all the denominators and use that. It usually is not the fastest way. It often gives you bigger numbers than you need. And it will do that here. But if I did that here, I have 3 times 5 times 5. 3 times 5 or 5 times 5 is 25. And 3 times 25 is 75. I can multiply both sides by 75/1. So this ends up being 75. Remember when we're multiplying fractions, we multiply across. So this is 75/3x minus. I then have. I'll do the substep here. 75 times 2/5 equals 3 times 75/5. That's 150/5, and this is 225/5. When you do this division, you get 25x minus 30 equals, oops, that's a minus there, not an equal sign, equals 45. And now we don't have fractions and we can solve. Add 30 to both sides. And I get 25x equals 75. And divide by 25. And I get x equals 3. best approach, though. Is lowest common denominator or least common denominator. And we did this before when we did fractions. Take the denominators. And rewrite the equation real quick. Do our little LCD chart. So instead of multiplying by 75, multiply by 15. The number's gonna be easier, smaller, and they cancel right away. And deliberately not combining them or multiplying those out. Because the 15 was picked because it does cancel the denominator. So you're better off just doing the canceling there first. In each case, 15 was 3 times 5. And I'll put that back in. If you just cancel out the number that's on bottom, this is 5x. Cancel out the number on bottom here, I have 3 times 2, which will be 6. And cancel out the number on bottom here, and I have 3 times 3. I end up with 5x minus 6 equals 9. Put something up here,
Can you
Yep,
push up the?
that's right.
Thank you.
Now we're not dealing with those big numbers and this is easier to do. Add 6, we get 5x equals 15. Divide by 5 and we still get x equals 3. We did do the LCD thing before, didn't we? Long time ago. I showed fractions in the notes before this. Chances are, in this class, if they give you an equation to solve, it probably is gonna have decimals and not fractions. That one's, I think, even a little bit easier, there's less thought involved. Folks are still writing, so I'm giving them a chance to write. Did you guys watch the debate? Oh my god, it was fucking hilarious.
Yeah, I saw it.
I missed some of the stuff at the beginning. And I saw it like on our recap later on. Like I missed where, I missed where. Trump said that immigration to immigrant people are eating other people's pets. I'm like, god damn, where the fuck did she get this shit, bro? That's just stuff the batshit crazy. And then like at one point, she just, I thought she was gonna call him this fucking piece of shit, I really did. It's right near the end, they're asking about negotiations with terrorists. She's talking about how he negotiated with terrorists and invited them to Camp David. And she started to go, and this, and you could see the fucking look of disgust on her face, and she paused for like 2 seconds and goes, this former president. But I swear she wanted to go, this fucking piece of shit. Oh my god, it was pretty entertaining, they both wanted to go after each other. Alright. Decimal quiz, everyone looks like they're done kind of writing. Let's say we had 0.5x plus 0.32 equals, I don't know, 0.2x minus 0.451. Easiest way to solve this problem, easiest way to clear fractions. Or not fractions, to clear the decimals. Count the decimal places. Count them in each. There is 1 in that one, there's 2 in that one. There's 1 here and there's 3 here. Use the largest answer. Use the largest count. And multiply. Everything. By 10 to that power. In this case. 10 to the third power here. That is a. Shorter way of writing, without using a lot of words. It's really 1 followed by that many zeros. So in this case, 1000. So we're gonna multiply by 1000. Or 10 to the third, and what that does is it shifts the decimal right 3 times. So I'm gonna make sure every number has 3 numbers after it. Just by filling in. Any missing spots with a 0 before I do my shift. So I added. These zeros. To make sure they all had 3 spots. Alright, now we'll do the shift. I'm gonna move the decimal right 3 times in all, each of these cases. And this becomes 500x plus 320 equals 200x minus 451. At this point, we have variables on different sides. We want to get them on the same side. We also have to do it where it balances. It still has to balance. I can do that here by subtracting 200x from both sides. $500 minus 200 is 300. Now we can do what we did before, we're trying to get X by itself, so we're gonna deal with the thing that's added to it first. We'll subtract 320 from both sides. And it looks like we're gonna get a shitty answer here when we do this final value. I don't know what that equals, but I'm gonna find out. -771 divided by 300. Not as bad as I thought it was gonna be. So that would be the value that solves that up there. Chances are, if you start with decimals, you're gonna end with decimals. I'm off screen.
Do anything else, like remove the decimal point, all that stuff.
No, if you clear the decimals, now it's just doing basic steps, adding, subtracting, dividing. You can always check your work by plugging it in. In fact, let's do that. 0.5 times -2.57. Plus 0.32. Does that equal? 0.2 times -2.57. Minus 0.45, but. So if I do 0.5. Times -2.57. And then I add 0.32 to it. On the left side, I have -0.965. And on the right side. I also get -0.965. So. It does work. We did have the right answer. Let me give you guys one to try. Since decimal ones are one of the ones that are likely going to occur for you. Let's do 0.21x. Minus 0.937 equals 1.45. Brittany, is this better the way it is right now? The lamps are on, or I'm gonna turn the lamps off real quick and see how it looks for you guys. Or is that better? This way or with the lamps on? Okay. You can answer?
Yeah.
How do you know it's the wrong one? Where'd you get it?
13.7536.
Yeah, that's the wrong one.
I got a 1.486
That's the wrong one also.
for us. Well,
11.366666 is the correct answer. So if I can see this one has the most decimal places with 3. So I'm gonna rewrite this so that everything has 3 decimal places real quick. By adding in an extra 0 where necessary. Don't worry, Bianca, a lot of people got it wrong. That's why we're doing it here, why we giving you practice in class.
I remember like.
Yeah, we're gonna do that in a second.
And then I got a different answer.
If I move the decimal 3 times, I got 210x minus 937 equals 1450. So we add the 937 to both sides. Got 210x equals, I got 7832. And if I divide both sides by 210. You're gonna get x equals 11.36666. And the 6's keep going, eventually your calculator will see a 7. Only because it's rounding to what it can show you. This is an unending decimal. We put a bar over the 6 to show that it doesn't actually end. Now, if you volunteer to round to any decimal place here. You will no longer get a correct answer when you plug it in. Only this one will give you a correct answer. It doesn't matter how many decimal places we round to. I'm gonna use what I have right here. And I'm gonna show you that value does not work. If we do that, I've got 0.21 times 11.3, how many 6's do I got here? 1, 2, 3, 4, 5, 6, 7, that's convenient. Then that's 7 minus 0.937. Does that equal 1.45? Gonna be really close.
I got.
6 base.
Round it out to.
It rounded for me. It fucking just said it was right. Holy shit, it gave me 1.45. I'm gonna do less 7s, let's try this. Let's round to 3 decimal places and see what we get. Apparently, it was happy with that. It said you're close enough on that one. Here I'm getting 1.45007 equals 1.45. And that's why I had so many 6's there. That the zeros pushed everything so far off the screen that it rounded to get rid of the 7.
I plugged it in as 11.6. got pretty close.
It gets close.
Yeah.
This shows you what, this is why you don't wanna round until the end. Avoid rounding till you're at the end. You're familiar with the homework right by now, it asks you for decimal places. Don't ever round any sub-step. Only round when you get to the final answer, and you're going, what am I plugging in? That's when you round. Avoid rounding till you have the answer you're plugging in. If this was a subset. If this was a subset. This error would propagate. Downward. Through all of my remaining steps. Or forward through all my remaining steps. And if I keep rounding along the way, every time there's like, you saw the standard deviation, there's a lot of steps. If you round too much, all those errors can round out where your final answer. Isn't even in the right ballpark. So you want to avoid that. And we'll call that a wrap for this hour.
That was fine.